All right, so last class we talked about factoring using two different methods, taking out the GCF and then factoring by grouping. This method today, we're going to kind of combine those two methods into what we're doing today. And so this first problem, just a little review, refreshing your memories, how to multiply two binomials. You remember we double distribute. So we multiply 3x to x, we multiply 3x to 3, negative 5 to x, and negative 5 to 3. And then we combine like terms. The reason I'm showing this is because our problems today are going to start here. Remember, this whole unit is kind of like the last unit in reverse. Last unit we multiplied polynomials together. This time we're working backwards to figure out what was multiplied to get there. And so today's problems, if you notice all of them in the examples, they're going to start here. And our answer, we need to work backwards to look like this. What was being multiplied to get there? Okay, so this is just another method that we're going to talk about. If you remember, factoring is like undoing multiplication. It's the opposite. And so our problems today, here's what they're going to look like. They're all going to look the same, and so we're going to use the same method over and over. But we're going to factor quadratic trinomials. This is why I had you guys know that list of words. So things that have x squared and 3 terms. Okay, that's what we're going to talk about today. Quadratic trinomials and how do we factor them. Well, your first step is to always look for the GCF. That's why we learned that factoring method first. You always look for the GCF first. And so if I look at 3x squared, 4x, and 15, well, 3, 4, and 15 have no numbers in common, so there's no number to pull out. And 15 has no x on the end, so we can't take any x's out either. What that means is there is no GCF. Okay, so we can't factor that way. Then we look to see if there's 4 terms. If there's 4 terms, we could do grouping. No, there's not 4 terms. But there's still a way to factor that, and we're going to call this the AC method. Okay, this is going to be called the AC method. Now here's why. So step 1, if you remember in a quadratic trinomial, it goes A, B, C. A, B, and C are the numbers. A is in front of x squared, B is in front of x, and C is the constant. So that number right there is A, that's B, and that's C. Okay. So step 1, we're going to multiply A and C together. We're going to multiply those numbers together, the A value and the C value. So in this case, we're going to multiply 3 and negative 15, and we're going to get negative 45. Okay, now here's what I have to do. I have to find 2 numbers. Listen carefully. I have to find 2 numbers that multiply to negative 45, and at the same time they add up to 4. So I need 2 numbers that when I multiply them I get negative 45, and when I add them together I get positive 4. And so I need to start thinking what numbers multiply to be negative 45. Well, I have negative 9 and positive 5, but if I add those I get negative 4. So I use positive 9 and negative 5. If I multiply those, I get negative 45. And if I add them, I get 4. So that's important, first of all. Step 3. Now I'm going to split up the middle term. The b value, basically. Here's what I mean by that. I'm going to rewrite this polynomial. I'm going to put 3x squared, but instead of putting the 4x, I'm going to use those 2 numbers I circled over here. I'm going to put minus 5x plus 9x instead, and then minus 15. So I found those 2 numbers, and now I'm splitting up the middle term. And the whole point of this, the whole point of me doing this process is because now I have 4 terms there. Now I can do what we did last class and factor by grouping. As soon as you get to 4 terms, we could factor by grouping. So I'm going to group 1 and 2. In group 1, I could take an x out, no numbers. I'm left with 3x minus 5. And in group 2, I could take a 3 out, and I'm left with 3x minus 5. And so if you remember by grouping, now I just write them as 2 binomials. That's step 5. Write as 2 binomials. So in one set, I'm going to have 3x minus 5. And in the other set, I'm going to have x plus 3. And I can check my answer. If I go back and double distribute this, I should end up where I started with. If you notice, that's the same as the very first review example we did. So there's my answer. Let's take a look at example 2 here. We're not going to do all of these because they do take some time. So step 1, we're going to multiply a and c together. And we get 9. That's why it's called the AC method. Now I have to find two numbers that multiply to be 9 and add up to negative 10. They multiply to be 9 and add up to negative 10. So I got to think of numbers that multiply up to 9. So 9 and 1. But if I add those, I get 10. I need negative 10. So negative 9 and negative 1. There's my two numbers. Now I'm going to rewrite this and split up the middle term. So I'm going to put 3v squared minus 9v minus 1v plus 3. So now I got four terms, and now the whole point of that was, so now I can factor by grouping. So put parentheses around group 1 and group 2. There's a minus between the groups. That means I got to flip that middle sign. Right there. Thank you. So now I'm going to take the GCF of group 1, take out 3v, and I'm left with v minus 3. In the second set, I can't take anything out. My advice would be if you can't pull anything out, put a 1 there as a placeholder. Technically, you can take a 1 out of anything, and it doesn't change anything. And that'll reinforce when you write your final answer that you need to put the 1 there. So my final answer, I'll have v minus 3 in one set and 3v minus 1 in the other. And again, I can always go back and double distribute to check that final answer. Let's look at D down here, because D is a little different. So I said back at the beginning that our first step should always be to take out the GCF if you can. Always look for the GCF first. In every factoring method we do, because there's going to be about 4 or 5 of them, look and see if you can take anything out of all the terms. And so I look at this next one, and I notice there is a GCF. I can pull a 2 out of the numbers, and I can actually take an n out of all the terms. So I take a 2n out of everything. And then I'm left with n squared plus 7n minus 60. Okay. Now I'm going to do that process again with this right here. Now I want to factor what's inside the parentheses. So I'm going to multiply a and c together, and I get negative 60. Because in this case, a is 1 now. Forget about the 2n for right now. That's going to be in your final answer, but for right now, forget about it. So multiply 1 and negative 60. Find two numbers that multiply to negative 60 and add up to 7. So I got to start thinking of numbers that multiply to negative 60. I have negative 10 and 6, so that's not going to do it. I got negative 4 and 15. That's not going to add up to 7. I could do, let's see, negative 5 and 12. If I multiply those, I get negative 60. And if I add those together, I get 7. So there's my numbers right there. So again, forget about the 2n out in front. We're just going to bring that down and put that in our final answer. But for right now, forget about it. So I have n squared minus 5n plus 12n. Oops. Plus 12n minus 60. And now I factor by grouping. Take an n out, n minus 5. Take out a 12, n minus 5. And so now I'm going to have n minus 5, n plus 12. But like I said, that GCF you take out at the beginning is always going to be in your final answer. You just have to remember to put it in at the end. So those three things are being multiplied to get what I started with. All right, we are going to look at one more example when we're solving equations. The whole point of this, we're going to use factoring to solve equations that are harder to solve. We haven't really solved equations that had x squareds in them before, and so that's going to be the whole point of factoring, to be honest. And so I have an equation here, so now I'm trying to solve, okay? So I'm going to factor like normal. Pretend it doesn't say equals 0 right now. Pretend it doesn't say equals 0. It does, but right now pretend like it doesn't. So I just want to factor this. I want to factor 5x squared plus 16x plus 12. So I look for the GCF. There isn't one. So now I'm going to do the AC method because I have a quadratic trinomial. That's when I use this method, when I have a quadratic trinomial. So I'm going to multiply a and c, 5 and 12, and I get 60. And I need two numbers that multiply to be 60 and add up to 16. They multiply to be 60 and add up to 16. So 10 and 6. Now I'm going to rewrite this. 5x squared plus 10x plus 6x plus 12. Then I factor by grouping. Pull out a 5x, x plus 2. Pull out a 6, x plus 2. And then I can have x plus 2 and then 5x plus 6. So nothing was different up till now. But now there's an equation I'm trying to solve, which means my final answer has to be x equals something. Anytime you're solving an equation, your answer has to be x equals something. So here's what I do when I'm solving an equation. This is important. I'm going to take each factor, so this x plus 2 and this 5x plus 6. Now understand what I'm about to do. I'm going to take each one of those, and I'm going to set up two different equations. I call them mini equations. I'm going to put x plus 2 equals 0 and 5x plus 6 equals 0. Basically, I'm going to end up with two different answers to these problems. I just solve both of these equations like normal, and I'm going to get two different answers. So on this one, subtract 2. So x equals negative 2. That's one answer. And over here, subtract 6 and divide by 5. There's my other answer. So the factoring is the same, but then when I'm solving an equation, I need to set each factor equal to 0 to solve. Next class, we'll talk about another factoring method, and then we'll have one more after that. So there's going to be 5 total. There's going to be GCF, grouping, AC method, that's what this is, and then we'll have 2 others coming up.